This video is going to be an introduction into graphing in 3 dimensions. We're going to see what coordinate space looks like, as well as how to plot points in coordinate space. Okay. Now, coordinate space is 3D. That's the world that we live in, and it's nothing more than the XY plane, the coordinate plane, combined with a third axis, which is known as the Z-axis. Let me give you a nice visual illustration here. So this is the coordinate plane that you're familiar with, right? The x-axis is in red here, and the green axis represents the y-axis, right? And I'm going to manipulate this now and bring in the z-axis, which is now in blue, okay? So this is a nice representation of coordinate space. You can see it just allows for more movements than we were able to achieve in the coordinate plane, okay? Now, there's, of course, endless applications to plotting and graphing in 3D in coordinate space. I think a really cool application is in 3D printing, okay? So here is a website. This is a MakerBot 3D printer, and on the website they talk about just some of the basics of how 3D printing works. And if you scroll down here, you'll see it's talking about how the printer set up with this coordinate space of an x-axis, a y-axis, and a z-axis. And every point of your 3D model has a unique position along the x, y, and z axes. And that's how the printer knows where to print, for any given object. Okay, so pretty cool. All right, so typically in mathematics, we represent on a 2D piece of paper or on a 2D screen, we represent the coordinate space in this manner, okay, which is a little bit different than how we represent coordinate plane, okay? So notice the position of the x-axis, okay? It kind of appears on our screen like the x-axis is going kind of up and down at an angle, but what we consider the movements that the x-axis controls are forwards and backwards, okay? The x-axis is responsible for forwards, which would be in the positive direction, and that would be this side of the x-axis, okay? Again, on your screen, it looks like it's heading downward, but really you need to think that's coming forward out at you, okay? And then backwards would be in the negative direction, which would be back here, okay? Now it's your y-axis that's controlling right and left movement, which is different than how it is in the coordinate plane, right? So this would be the positive side of the y-axis, and then going to the left would be the negative side. And then finally, the z-axis is going to control your up and your down movement. So up, of course, is positive. That would be right here. And then down is negative. Okay. And then you can kind of see the parallelogram that I have drawn within the coordinate space there. That dashed parallelogram, that is a representation of the XY plane, the coordinate plane that you've been working with for several years now. So it kind of gives you an idea of how that coordinate plane fits into this representation of the coordinate space. Okay. All right, so let's talk about plotting points in coordinate space. Points are graphed using ordered triples, okay, instead of ordered pairs. They're called ordered triples because they have 3 coordinates, x, y, and now z, okay? Let me give you a visual illustration once again of how this can be done. Okay, so notice the orientation of coordinate space here. It matches what I had on my screen earlier. And here I want to plot the point of 3, 2, 1, where 3 is my x coordinate, 2 is my y coordinate, 1 is my z coordinate. So I'm going to, from the origin, which is the intersection of the three axes, I'm going to move 3 units forward, 2 units right, and then 1 unit up. And that is where my point gets placed. And we can kind of move this around and you can kind of see that point represented from different angles. Okay. All right. So the tough thing about points in coordinate space on a 2D paper or 2D screen is um, it's really hard to tell their location if you don't draw in the three-dimensional box that's associated with that point. Okay, so you can see on your screen here in my examples, I'm trying to find the coordinates of the point that's been plotted and describing its location in relationship to the origin. Okay, so you have a box associated with each point, and what the box does is it leads you back to the coordinates, the x, y, and z coordinates that are associated with a point. So notice in A here, that point, the box that goes along with it, it's intersecting the x-axis back here at -3. So that means the x coordinate of that point is -3. Then it's intersecting the y-axis at 3. I'm sorry, also -3. And then it's intersecting the z-axis at +3. Without that box there, it would be really tough to tell the actual positioning of that point. Okay. And so you can see in terms of the location in relationship to the origin. So to get to that point from the origin, you would be moving 3 units back, then 3 units left, and then 3 units up. Okay. All right, let's do the same thing for the point over here. The x coordinate appears to be at 4. And you're just following the box. You're seeing where the box that's associated with the point intersects the x-axis. And now the y-axis, that appears to be at 3. And then the z-axis, way up here, I'd say at 5. So for this point from the origin, you would be moving 4 units forward, then 3 units to the right, and 5 units up to get to it. Okay. Now let's plot points ourselves, all right? And we're going to have to draw the three-dimensional box associated with the point to make sure that we're nice and accurate, okay? So in order to draw the box to lead you to the final location of the point you're actually trying to plot, you're going to plot several other points that form the different corners of the box, okay? So the first point you always plot is going to be the origin. Okay, one corner of the box is always positioned at the origin. Okay, and then you can see the point that I'm trying to plot here. It's -3, 3, -4. Next, you're going to come up with like x, y, and z intercepts associated with that point. So the x-intercept would be -3, 0, 0, which would be back here. The y-intercept would be 0, 3, 0, which would be right here. And then the z-intercept would be 0, 0, -4, which is down here. Okay. And hopefully you can kind of pick up on what I did there is I just took the original point that we're trying to plot and I came up with different combinations where 2 of the 3 coordinates became 0. Okay, Now I'm going to do the same thing, but making only one of the three coordinates 0. So now I'll plot -3, 3, 0. Okay, so that means from the origin, you'd move 3 units back, and then you'd go 3 units right. And here's where it's kind of tricky. Notice where I'm going to place this point. I'm going to place it right here so that when I draw a line back to the y-axis, see how that line is now parallel to the x-axis, okay? Then I'll plot -3, 0, -4. So from the origin, you're moving 3 back, and then you're going to go from that particular location 4 units down. That's going to take you right about here. You don't actually go all the way down to where -4 is located on the z-axis. So you can see if I connect these 2 points, see how that line is parallel with the x-axis once again. And then finally, I'm going to plot 0, 3, -4. So from the origin, you're going to move 3 to the right and then 4 down. Places you right here. And connect those 2 points. See how that line's parallel with the z-axis. I connect these 2 points parallel with the y-axis, and then start connecting the rest of your points. Hopefully you can start to visualize this box being formed. And notice there's one final point that's missing to finish off the box, and that's the point that we're after. It should be right around here, so that when I connect there and there, as well as here, here, I can finish off that box. And then while we're at it, I'm going to make this dashed as well. So you kind of see like where's the front of the box and the back of the box. Okay, so this point ends up being right there. Okay, you're moving from the origin 3 units back, then 3 units right, and 4 units down to get to it. Okay. All right, let's do one more example together to hopefully drive this home. So once again, I'm going to plot the origin as my first corner to the box. Then I'm going to plot my x, my y, and my z axes or intercepts. So for this point, x-intercept would be at -3. Y-intercept, 0, -4 is 0. That's 4 to the left on the y-axis. And the z-intercept would be 0, 0, 2. Okay, and how about I just start to connect all of those back to the origin. All right. Now I'll come up with all of my corner points whose coordinates, one of them is 0. So that would be -3, -4, 0. From the origin, move 3 back and then 4 left. That's going to take me to right about here, so that when I connect these 2 points, see that line is parallel with the x-axis. And then this line is parallel with the y-axis. Next point will be -3, 0, 2. Okay, so that's 3 back and 2 units up. Connect here to be parallel with the z-axis. Connect here to be parallel with the x-axis. And then final point I'm going to plot before the actual point is going to be 0, -4, 2. So we're going to go 4 left and 2 units up. Okay, so hopefully you can see where that final point should be located at, right about there. so that I can finish off the box now. So this point is right here. Make sure it makes sense with relationship to the origin. So you're moving 3 units back, you're moving 4 units left then, and 2 units up. Okay. All right, now it's your turn to practice on your own. Go to practice 1. Try to plot that point yourself, following the procedures we've done here in these 2 examples, and then come back to the video and check your work with mine.